All right, this video is going to show you how you will use Gaussian elimination operations to solve a system. So I've given you a system right here, and you are going to use that to create a matrix and then use matrices and Gaussian elimination to solve it. And here's how it works. Remember that when you are given a system, use the coefficients only. So I have 4x and I have 2y. So using x in the first column and y in the second column. Down in the second row I have negative 4x and I have 3y. And this equals 9 and 16 respectively. Now what does that look like as a single matrix to be able to solve? It looks like 4, 2, 9. So there's your 4, 2, and 9. And negative 4, 3, and 16. So remember, we are trying to get to some form of reduced row echelon form. So that's going to look like 1, 0, A and 0, 1, B, so that x equals A and y equals B. We're trying to figure out what those will be. There we go. So what do we need to do? Remember that this is row 1 and this is row 2. I see that I have a 4 and a negative 4, so I can create a 0 in this space by adding row 1 to row 2. So I'm going to take row 2 and I'm going to add row 1 to it. So what row am I affecting and what am I doing? So I'm not affecting row 1 at all, but row 2, I'm going to take negative 4, add 4 to it. 3, add 2 to it. 16, add 9 to it. And now I have that. One step closer to reduced row echelon form. You can see that we have a 0 here and we have a 0 here. So next, we're going to look at, I see 5 and 25. I could scale that. I could divide that by 5. So that's what I'm going to do. I'm going to take 1/5 of row 2. So I'm not affecting row 1 at all. I'm saying 4, 2, and 9 are unaffected. But when I divide 0 by 5, I get 0. When I divide 5 by 5, I get 1. And when I divide 25 by 5, I get 5. And now I am another step closer to reduced row echelon form. Now that I have this, let's go ahead and work on this top row. I have a 4, 2, 9, but I want this to be a 1. So maybe what I'm going to do first is maybe I'll get rid of this 2, maybe try to turn that into a 0, because if I try to divide 4, 2, and 9 by 4, it'll work, but it'll give me a gross fractional situation that I maybe don't want to do. So instead, let's go ahead and subtract from row 1. I'm going to subtract row 2, and I'm going to do that 2 times. And if I subtract row 2 from row 1 2 times, I can turn that to 0. So taking 4, and I'm subtracting from it 2 times 0, which is nothing, no change. I'm taking 2 and subtracting from it 2 times 1. And I'm taking 9 and I'm subtracting from it 2 times 5. So see how I'm taking row 1 minus 2 times row 2 for each. So affecting row 1, I now have 4 minus 0 is still 4. 2 minus 2 is 0. And 9 minus 10 is negative 1. And I have not affected row 2 at all. And now I have yet another step toward reduced row echelon form. So the only thing left now is to fix that. And the only way to fix that is to scale row 1 by 4. So I'm going to take 1/4 of row 1. So not affecting row 2 at all. I can go ahead and write row 2. But row 1, 1/4 of 4, 1/4 of 0, 1/4 of negative 1. Gives me that. And now I have reduced row echelon form completely, which means that I have 1x plus 0y equals negative 1/4. I have 0x plus 1y equals 5. And so I can simply say that x equals negative 1/4 and y equals 5. And this is how you put it as an ordered pair solution. X is first, y is second. There is your solution. I'm going to show you one more example, and then hopefully you'll be able to do the third example on your own. But maybe go ahead and try this one on your own. See if you can get it close to what you'll see me do. Pause it and try it on your own first. All right, so I'm going to skip the part where I set it up like this, and I'm going to set it up straight into my solving matrix. So 4, 3, and 10, 1, 2, and 10. So just taking the constants from each row. I see that I already have a 1 here, so I'm going to switch these two rows so that the 1 is up here. So row 1 is going to switch with row 2. So now I have 1, 2, and 10 on top, and I have 4, 3, and 10 on bottom. Now I want to get rid of the 4 here. I want to turn it into a 0. So I'm going to subtract row 1 from row 2 4 times. So row 2 minus 4 row 1s. So I'm not affecting row 1 at all. But now 4 minus 4 times 1, 3 minus 4 times 2, and 10 minus 4 times 10 is what I'm doing. So I end up with 0. 3 minus 8 is negative 5. And 10 minus 40 is negative 30. Once I'm here, I can see that I can scale this by negative 5 because everything can be divided by negative 5 evenly. So that's exactly what I'm going to do. Negative 1/5 of row 2 is what I'm trying to do. So again, not affecting row 1 at all. But now negative 1/5 times 0 is 0. Negative 1/5 times negative 5, the negatives cancel. 5 times 1/5 is 1. Negative 30 times negative 1/5, the negatives cancel, and 1/5 of 30 is 6. Now that I'm here, I just need to fix that too. I have my 1s down the diagonal exactly how I want. I have a 0 here, I just need a 0 here. So I can't multiply or this by 0, I cannot divide it by 0. The only thing I can do is subtract row 2 from row 1. So I'm going to take row 1 and I'm going to subtract row 2 from it, and I'll have to subtract row 2 2 times to get to a 0 here. So row 2 is unaffected, but row 1, 1 minus 0 minus 0, 2 minus 1 minus 1, 10 minus 6 minus 6. And now I have reduced row echelon form, where I can now say that 1x is equal to negative 2, and 1y is equal to 6. So my solution is that. I can go ahead and try this last one. And all I'll do is I'll give you a spoiler. The answer to this last one is, pause if you don't want to hear it, -7, -8. See if you can get there on your own. There is no one way to get there.